Hello everyone, this is Ritesh Suteri and today we are discussing this problem, that is palindrome partitioning. So here is the problem statement which says that we are given with a string s and we have to partition s such that every substring of the partition is a palindrome, and we have to return all the possible palindrome partitionings of the s. Here is one such example given, and here is the sample output of that as well. So let's jump directly into our whiteboard and let's see how we have got this answer. So here is the input and here is the output of that. So let me write this here and let's reduce the answer. So first of all, obviously the method that I'm using right here is recursive method, and it is pretty standard stuff with recursion, that we will pull out the first character and we will call out the recursion for the rest of the string, and from the answers received from the rest of the string, what we will do is we will add this answer, add the answer of this in the result, and we will prepare our answers for that. Similarly, we will repeat this step further and we will expand our search to 1 plus character. Initially we were taking this a only, then we will take this a into our consideration and we will call the recursion on the rest of the step. Similarly, we will move further with the rest of the string until we reach the point that we end up in a situation that we have an empty string to deal with. So don't worry, I'm not explaining the recursive tree right here. I'm just making you comfortable with the way that I'm dealing, so that when we discuss the bigger example you won't feel cut out. So it's just simple stuff. First of all, we'll pull out a here and we will call out recursion. So let me write rec for the rest of the string. Also, there is one more important stuff that needs to be discussed here. That is, when we have pulled out this character, and since we are trying to form our answers from this recursive call and this pulling out the characters, so it is important to make sure that the string that we are pulling out should be a palindrome in order to make a recursive call. Why? Because suppose if we reach a situation wherein the character that we have pulled out is AB, right? So in this situation, AB is not a palindrome, and if we don't have a palindrome, so there is no point of forming that answer. Why? Because that each answer, each array should have strings that that are necessarily to be a palindrome, right? So if we at any stage encounter a string that is not a palindrome, so we'll stop our answer here, stop our recursive call right there, and we will not make call for that. So I hope I'm making sense with this point now. So let's get to a point. Since a is a palindrome, right? Because individual character is anyways a palindrome. So we'll call out for the recursion in the rest of the string, that is AB. Similarly, it is pretty standard stuff that for this we will pull out A here and we'll call for recursion on the rest of the step B, and the B will pull out B here and we will call recursion on empty string. And calling a recursion on, we will handle this base case here wherein we reach this part, we will end our execution and we'll return our suitable answer for that. I'm not going into how we are going to construct this and what thing are we returning here. I'll go into this part later in the code. So you can see that we can clearly find out the first answer, the first array from this part, AAB. So this is our first answer. Then, as we discussed earlier, we will take two values from here, AA, and we will pull out these A values, and since AA are palindrome, so we will have to call function or recursion on the rest of the string B, and for B we will pull out B here because B is a palindrome. We'll call recursion or function whatsoever we'll write, and on the empty string again we'll handle this in the base case, and the answer we will get is this. So AA comma B will be our answer. Now for the next iteration or for the next step, we can say that we have to consider AAB. But as I have discussed earlier, that at any stage the thing or the initial characters that we are pulling off, let's call it prefix for now. I think we are using prefix in our code as well. So yeah, so at any step, if we handle or if we encounter a case wherein prefix is not a palindrome, we will not go any further. So these all are the only possible values of these answers. So I hope I'm making sense now. So let's look out for any complex example now. Okay, before that I've jotted down a few steps so that we are all on the same page before making this complex recursive tree and you don't feel out lost. So the first step is that we will take out, or we will begin from the start and we'll start capturing the values one by one that I've discussed in the example. The next step is we have to prepare a string, the prefix string, and we have to check it that if it is a palindrome or not, because it is our only way to check that individual characters that we are assembling is palindrome or not, so that we don't form an invalid answer. So if the prefix part is a palindrome, then we have to add that to our path or to our answer. Don't worry, I'll tell you this later in the code that how we are forming our answer, and we have to call the recursion on the rest of the string. Also, one more thing that some of the people might be scratching their hand and they might be thinking that we are checking only for the prefix wala part. How will we be checking for the answers returning from the recursion? So if you are a person like that, so I would highly recommend you guys to please clear your concepts regarding recursion and then continue with this video. So if that is the case, I mean, if we have done with this much part, so there is one special case, I mean, that I need your attention upon. But this is a pretty this might be a case, I mean, you might not be able to get this by now, so I'll discuss this later in the video. By the way, it is a highly important thing that we need to keep in our mind before coding. Don't worry, I'll discuss this in later. So also let's look upon this PC. Oh, don't worry, this is base case. So in the base case, what we have to do is the base case is pretty standard stuff that if string is empty, we will have to add path. Path again, I will tell you later in the video that what is path and how we are constructing our answer in the path, and we have to combine it, or we have to return this into an answer array, and we have to return that because we have to return a 2D array, right? Arrays of array, I mean array of arrays. So for each base case we hit, we have to combine this path in an array and we have to return this inside an answer array, right? We'll look this later in the code. So if that much is clear to you guys, let's take another example. Maybe let's take a bigger example for now so that things will be clear to you. Okay, let's take an example that we have AA BB, right? So this is a very important step, so I want your utmost attention into this because we are dealing with this greater example, and if you get this part, so most of your question will be done. So as discussed earlier, we will start by pulling this first part. We'll pull this out and we will call a recursion. Let me write P for partitioning. I think this this reference you will be able to get. So we will get partitioning on the rest of the string, right? So this is the pulled out character, or this was the prefix, and this is the recursive call, right? So in each step I'll be writing it this way. I hope let's make it this so that you are not confused about this. So this is the prefix and this is the recursive call. So I think you are okay with this syntax now. So at the next step, what we'll do is, with this step we will call out, I mean we will pull this character out A, and we will call recursion or the partitioning on the rest of the string, that is BB, right? I'm doing it this recursive way, so I hope you are able to get this way. And after the next step, we'll pull out this B from here, call out recursion on the rest of the thing, that is B. Similarly, we'll, as we move forward, I mean as we move ahead, we can see that we'll have to pull out B from here, and this will be empty string. So for the empty string, as I've told you that this will hit a base case and we will start returning back. So from this part you can see that if we return from here, and since we have only B and we have dealt with this part, so there is no further call available for that. Or if you want to make this or more further, you can pull out, okay, we have done this part, so no worries for that. So after that you will return to this part. Now in this part we have only considered this B. We have another case left wherein we have to take these two values. Why? Because we have, at each step what we do is we first of all take this one step and then we move ahead with the rest of the string, by increasing our horizon. Also, one thing that I forgot to you telling while making this recursive tree, that at every step when we were pulling out characters, we were checking that if a is if this character or the if this prefix string is a palindrome or not. Since at all of these steps these were simply one character, simply one character, so I've told you earlier that if we have single characters, they are anyways palindrome, so we have not explicitly checked for them. But yeah, we should ideally check for them. So, oh yeah, after that, when we reach at this, let me take another pen. And yeah, with this step what we'll do is we will now pull out these two b's from here, and we will check if these two b's are palindrome or not. Yeah, these are palindrome, right? So we will call for the recursion on the empty string, and from this part, this hit a base case and this will return its answer. And when we reach at this step, we have considered both of this part, so there is no other call left with that. So our program will move from this point to this point. Now at this point you can see that we have only took a till now. What we have to do now is, let's take another pen, we have to consider this AB now. But as you can see here that AB is not a palindrome, so there is no point of making a recursive call with that. So we will skip this part and we will move further. We will move further with ABA. Again, ABA is not a palindrome, so we'll skip this part as well. Sorry, ABB is not a palindrome, so we'll skip this part and we'll not make any palindrome, recursive call from here. So I hope this part is clear. And you can see that with this part, we have made our first set of answer. So let's write the answer here, A, B, B. And we have also made another set of answer from here, B, A, A, comma, B, B. Right? So we have got two set of answer from here. Now what we have to do is, let's take another pen. Now let's take these two parts from here. Since AA is a palindrome, so we will pull this out, AA, and we will call recursion or partitioning on the rest of the string. Now we will again put this B out and call recursion on this B, remaining B. Again, the next same step, we'll pull out B and we'll call recursion on the empty string. Empty string may we know that we'll hit the base case and we'll return from here. And there was single B, and that too we have handled here, so there is no point of making any other call here. So we'll reach this part, and when we reach this part, we find out that we have dealt with we have dealt with this much B only. So what we will do is we will take another B into consideration and we will make a function call. So first of all, we'll pull out BB and we'll make a call with empty string. So again, at this stage we hit a base case, so there it will return further, and when we return at this pass, we have already handled these two B's, so there is no other string left. So return from this stage till here, right, till the main string. Now you can see that at this stage, let's take another pen. Yeah, we have got another sets of our answers as well. So our answer includes AA, comma, BB, and our answers include AA, BB. Okay, AA and BB, right? And now we have to increase our horizon, and we can move from these two A's to including this B into our answer as well, into our prefix sum. But if we include this part, this is not a palindrome, so there is no point of making recursive call with that. Similarly, when we move, okay, there would be no call with AABB. Let's not write it here, right? And then at the next step, what we have to do is we have to increase our steps, and with this we have to include AA and BB. But again, AABB is not a palindrome, so there will not be any palindrome. There will not be any any recursive call with that as well. So with this step, I hope I have made this recursive tree clear to you guys, and these will be the set of answers that are possible for us. So if you are not sure about this, I will recommend you to please skip the videos and try to grasp this concept. Only if you have got this part till here, then only start with the code. So yeah, that was the stuff. And let's now look at the code that I've done here, and let's see. So since the function that we have to write here is, okay, let's take another pen. Sorry. Okay. So just a minute. So yeah, this was the stuff. And what we have done here is we have made a path array list, and this path array list will contain the values that we are getting while creating the recursive call, right? And since this function that we have built in, that we have a built-in function that does not include the start or end of this, so we are making a helper function for that. So this is the helper function. So this will receive a index is the starting point of the string that we have to deal with. Suppose in this case that initially we will take out a and the rest of the string will be ab. So what we will do is we will not modify the string to pass in here. What we will do is we will pass directly the index of this that from which index this string will pass. So yeah, index is for that purpose. Then we have string, obviously, then a path variable that will contain our final answers, and this result variable that will hold the resultant answer, right? So in the base case, what we have to do is path may anyways we will be calculating our answer. So we will wrap this answer inside outside we will wrap this answer by adding this into result, and we will return that result finally at the end. So this loop, what we have done here is we have started the traversal from the ith index, and we will go till we reach at the end of the string. Now the first part is, this is the prefix wala part that I've told you in the while discussing this recursive tree. So you can see that we have took the substring starting from index, and we have gone till i+1 index. Why i+1 index? Because when we use dot substring method, the last index that you get is this -1. I mean, if I write i+1 here, so the last index that I will have is ith index. So that's why we want from the starting of the string till the ith index, I mean till the index that we have reached. So we will get this answer in the prefix. And then what we have to do is we have also considered the rest of the string, and the rest of the string will obviously start from i+1 index and will go till the end. And this is the pretty much syntax for to write the same. Then we have done is we have checked for this prefix string to be a palindrome or not. If it is a palindrome, then only we will add this prefix to our answers. And if we have done that, we have to call recursion on the remaining string. So this is the recursive call for that. Then this is the stuff that I was talking about, right? So what happens is let's go into this recursive call, and let's find out that okay, let me open it sidewise. So yes, you can see here that we I mean at each step when we get this prefix array. Okay, let's also open the code now. Yeah, let's also delete this. So at each step so at each step, if it is a palindrome, what we'll do is, okay, what else it is opening? So what we will do is we will add this into the path, right? So we have add this b into the path, or maybe first of all we'll add a into the path. Then in the next step we will add this a into the path. Then at the next step we will add b into the path, and at the end we will add this b into the path. Now once we have incurred this case, or once we have dealt with this case, what we have to do is we will hit the base case here and we will return the answer right here. But you can see that we have made we have copied this path variable for all of this recursive call. So these value will be added into the final answer, I mean into the path variable. So after we have prepared the answer, we have to do is we have to remove these variables from while backtracking into the previous call. So what we have done is at every step this value will be at the last step of this path variable. So after forming the answer, we will, because once this call is over, that means we have prepared our answer for that, so we have to remove the last value, that will be b. So this step will do is it will remove the value from this path variable so that it will not disturb other answers as well. So I hope I am making this sense now, but if I am not making sense this now, so do one thing, do comment this statement and let's run this. Okay, I'll do this later in the program. So yeah, comment this statement and dry run this or run against sample input, and you will find out what I'm talking about, right? So after that, this was the function for that, and there is pretty simple stuff for palindrome function. Palindrome, I hope all of you are able to make it, that we will check for from the starting and from the end, that if at any point these values are different, we will simply return false, else we will return true at the end of the loop. So this was the stuff. Let's run this code. First of all, let's try run this, or let's test this against sample inputs. So yeah, this is working very fine. Let's use example test case. Now here is the thing that I was talking about. Let's comment this out, right? Notice here the answer is AAB and AAB, right? Let's run this output and let's see what I was talking about. So you can see that the first answer that we got was perfectly fine, but at the second example you can see that we have these values that are that were exactly same in the previous example as well, in the previous array as well. So these values are copied here as well. So what we want to do with this is we want to remove these values from here. So that's why we have done this statement. So anyways, I think this is clear to you by now. So let's submit this code and let's see if it works or not. So yeah, it is working perfectly fine. So that's all for this video. If you like my explanation, you can like the video and you can consider subscribing to the channel as well. So yeah, that's all for today, and thank you everyone.